Astrophotography is probably the most technically challenging, gear-intensive genre of photography. You've got super expensive gear, labor-intensive post-processing, you're creating complex composite images, and using highly sensitive specialized equipment. Even entry-level astro is pretty hard to get right. And I'll tell you, in order for your images to be good, you're gonna need to do a lot more than just point your camera at the sky for a 30-second exposure. And that's what I did, and my images were just okay. So, given the fact that a modern astrophotography setup might look like this, how the heck were they photographing galaxies on glass plates in the 1800s? Astrophotography has always involved a combination of cutting-edge technology and creative solutions, and it is pretty interesting to learn about how the cutting-edge technology of each era produced these increasingly astounding glimpses of the universe around us. So, in today's video, I'm going to tell you all about the early history of astrophotography, how these incredible images were made with early photo technology, and how our understanding of the cosmos evolved alongside our ability to photograph them. If that all sounds interesting to you, then you should stick around. You can leave a like on this video if you like it, you can subscribe to my channel to see more like it, and you can leave a comment letting me know what you think. Have you ever tried astrophotography? How did it go? Did you get better results than I did? Hopefully you did. With all of that said, and without further ado, let's jump right in and talk about the dawn of astrophotography. Is that a pun? Kind of? Dawn is a celestial phenomenon. So, the first telescopes were invented in 1608 by two different eyeglass makers in the Netherlands. Galileo heard about this and built his own improved version and began using it to observe the heavens. Now, photography had not been invented yet, and it wouldn't be invented for another 220 years, so I might be starting this timeline a little bit early. But Galileo made sketches of his observations of the heavens, and those sketches survive. So here is the moon, captured in detail for the very first time by Galileo Galilei, and I think that's just so cool that I had to mention it. Also, I think this would be a super sick tattoo. Fast forward a few centuries later, photography is invented in 1828 by Nicéphore Niepce, and the chemistry was quickly improved on by Daguerre, and by 1840, early photographers are turning their lenses towards the stars. The first person to ever try and photograph the heavens was Louis Daguerre himself, who attempted to photograph the moon in 1839. But he was unsuccessful. Because, you see, the moon moves. And if I know anything about early photography, it's that movement is not its friend. So the telescope that you're photographing through actually has to track the moon. It has to move with it. And if it doesn't, you're going to get motion blur as the moon tears across the sky during your 20-minute exposure. So equatorial mounts are necessary for photographing space. And this is a device which compensates for the Earth's rotation by having one rotational axis that is parallel to the axis of the Earth's rotation. And these devices allowed astronomers to take very long exposures without losing focus on the subject or getting motion blur. Very cool. Very important invention also. So Daguerre failed. Editing Yvonne here, just popping in. There are some people on the internet who are saying that this photo is the 1839 photo taken by Daguerre. It is not, okay? There are a bunch of different websites saying this. There's some articles about it. There's a Reddit post about it. It is not Daguerre's photo. The earliest instances of this photo appearing online attribute it to John William Draper, who we're going to talk about in a sec. I don't think it's John William Draper's photo either, though. The only version of this image is this super low resolution image. There's no scan of it that shows the original plate that it was taken on, and I can't find an instance of this photo being posted by any kind of like archive or museum, you know, a reputable source for vintage photographic plates. So I'm sure this is a vintage photograph. It's definitely not from 1839, I can tell you that. It definitely wasn't taken by Daguerre. It probably also wasn't taken by John William Draper, and I think this is probably a later photograph, probably a wet plate collodion. Just wanted to clear that up because it's gonna be a historical misconception soon. I can see the first seeds of the historical misconception being planted online, and I just wanted to nip that one in the bud. But the first successful astrophotograph was soon taken in 1840 from a rooftop observatory in New York by John William Draper. He used an exposure time of 20 minutes to capture the moon and captured it through a 5-inch double convex lens telescope, as written in his laboratory notebook. In his notebook, he states that he exposed a prepared plate to the moonbeams. I love that. That is great language. Moonbeams. So this photo is cool. It doesn't look crazy technically impressive yet, right? But let me tell you, the technology improved really fast. Between 1840 and 1860, there were a ton of landmark achievements as scientists and inventors, back then I believe they were called gentlemen scholars, worked hard to improve on existing telescope technology so that the telescopes could let in more light and be more useful for photography. In 1842, the first photograph of a solar eclipse was captured by Jean Alessandro Majoshi. You're gonna make me pronounce names in this episode, aren't you?
Majocchi.
Wow, that's not how I was saying that. In 1842, the first photograph of a solar eclipse was captured by Jean Mailloki, and unfortunately, this image has been lost to time. But the oldest surviving eclipse photos, as far as I can tell, were captured in 1851, and these were taken by Julius Berkowski in Prussia during an eclipse that was visible for much of the northern hemisphere. He was commissioned to photograph this event by the Royal Prussian Observatory, and did so with an 84-second exposure beginning at the moment of totality. Looking at the photo afterwards, observers deduced that the prominences shown must be part of the sun, giving scientists their first ever look at the solar corona and solar activity. That's pretty amazing, and actually, we are going to come back to solar eclipse photography later, because it has had some pretty landmark impacts on our understanding of the universe and how things work, so put a pin in that. In 1845, the first photo of the sun was taken, and here it is. It looks a bit spooky to me, man. I don't know. Honestly, a lot of space photographs look a bit spooky. Like, even the ones from the 80s and 90s of the planets just look yee. But this photo was taken by Leon Foucault and Hippolyte Fizeau on a 5-inch plate using an exposure time of 1/60th of a second, which is a somewhat slow shutter speed by today's standards, but was very, very fast in the 1850s. These are all taken on daguerreotypes, right? And daguerreotypes have an ISO rating of about 0.05. So the fact that they were able to capture anything up there is kind of remarkable. Portraits captured on daguerreotypes would need several minutes of exposure time, sometimes as long as 15 minutes, right? So 1/60th of a second is pretty fast, and it gives you an idea of how freaking bright the sun is. If you didn't already have an idea of that, I guess, by looking at it, by experience anyway. In 1850, the first photo of a star, other than our own sun, was captured by John Adams Whipple and William Church Bond. And that star was Vega, that really bright one that sometimes gets confused for a planet. And this photo was taken on a daguerreotype using the Harvard College Observatory's 15-meter refracting telescope, known as the Great Refractor. The exposure time for this shot was 20 minutes. And with exposure times this long, it was time to move on from the daguerreotype. In 1851, photographer Frederick Scott began experimenting with a process known as wet plate collodion, and this quickly became all the rage. You see, wet plate collodion was cheaper than daguerreotype. It allowed for multiple prints to be made from one negative, and it produced much sharper detail. But most importantly, it was also much more light sensitive, with an ISO rating somewhere between 1 and 3. Several stops faster than its predecessor, still not very light sensitive by modern standards, but unfortunately, because it's a wet plate collodion, the plate has to stay wet during exposure. So long exposures could only be so long that the thin layer of chemical doesn't dry out during the exposure. And without being able to create these ultra-long exposures, you could still mostly only photograph the brightest and therefore nearest celestial objects. So we got some fantastic photos of the moon and eclipses, etc., but it didn't really help push the boundaries of what we could see. Fast forward real quick to modern times, if you're interested in pushing the boundaries of what your clients can see, then you might want to check out the sponsor of today's video, PicDrop. PicDrop is a photo sharing platform designed by photographers and for photographers. You can upload your photos to these super customizable galleries that look like little web pages for each set. You can change font, background color, image size, and the header image to really customize how your photos are presented. Presentation is so important when you're sharing your artistic work. And if you're making custom galleries for each client, that's really gonna add that extra little bit of polish that will make your photos pop. PicDrop also has a full suite of tools that make it easier to collaborate with creative partners. Let's say you have a makeup artist, a creative director, and a stylist on your team. You can use PicDrop's collaboration mode to gather feedback from your team members on which shots are the best and which ones don't make the cut. You've got colored flags, comments, likes, and scribbles, a ton of options for folks to add thoughts to your work and make collaborations even easier. You also have the option to get notified when photos are downloaded, so you can tell when your clients access the gallery and which photos they chose to keep. If all of this sounds good to you, then you're in luck, because you can get 2 months of PicDrop for free by using my code YHansen at sign-up. So go and check it out, link in the description below. I think you'll love it. And a huge thank you to PicDrop for sponsoring today's video. Okay, so wet plate collodion was great, it gave great detail, but it dried out too fast to do long exposures. Luckily, an alternative emerged in 1878 when Charles Harper Bennett's experiments with dry plate process finally paid off after 5 years of fiddling with the new approach. Dry plate had been around for a while, but it had some drawbacks, particularly its very poor light sensitivity. Bennett discovered that prolonged heating of the plate would substantially increase light sensitivity, making it a much more useful technology. And now that you could put chemicals on a plate, have them dry, and then take a photograph with that later, it was suddenly possible to to package these plates as a consumer good, which is pretty cool. And so in 1881, the very first commercially produced photographic plates became available through the Eastman Film and Dry Plate Company. The photography boom was underway. This first decade of dry plate technology was huge for photography, and especially so for astrophotography. The new process allowed photographers to capture details never before seen in the skies. And in 1880, Henry Draper, he's like a really big name in astro, and he's actually the son of the guy who first photographed moonbeams. He captured the first photograph of the Orion Nebula using a 50-minute exposure and an 11-inch telescope. At first, it didn't look like much, but a year and a half later, he created a 137-minute exposure that captured the nebula in much more detail. And wow, now that is a proper space photograph at last. You know what I mean? Like, this is some good stuff. Andrew Ainsley Common captured some pretty jaw-dropping images in 1883 using a homemade telescope, and these photographs, and others like them, showed for the first time details that were not visible to the human eye. You see, the long exposure times allowed light to collect on the plate in a way that is not possible in human eyes. And this could be a whole tangent. I had a lot of fun researching this, but apparently the human eye is extremely light sensitive. Like, it can get up to 800,000 ISO in dark conditions. But the shutter speed of the human eye is between 1/100th and 1/200th of a second. So we don't do long exposures. We do like very high ISO, very fast exposures. Our eyes don't keep track of where photons land over a prolonged period of time, unless you're like staring at a really bright light, but I think that's a different process. Or maybe it's the same process, I don't know. Photography was finally showing aspects of the cosmos that we did not have the inbuilt technology to detect. So me looking through a telescope, I cannot see these details in the Orion Nebula. So with this new technology began a golden age of astrophotography, and finally astrophotography was a really useful tool in the study of astronomy. This 1888 image by Isaac Roberts was the first image to show the spiral structure of a galaxy. But he titled this image The Great Nebula of Andromeda, because that's what he thought it was. He thought it was a nebula, a collection of dust and gas in a spiral shape contained inside the Milky Way galaxy. Like, surely it's not a collection of billions and billions of stars identical to our own, hundreds of thousands of millions of light years away, right? That'd be crazy. It would be another couple of years before astronomers put that one together. Isaac Roberts took a ton of really beautiful celestial images. Here are a few of my favorites. Like, you've probably seen these on Tumblr. If you ever had like a really vibey Tumblr mood board, wow, these did numbers. Other nearby celestial objects got their first close-ups during this period as well. Jupiter was first photographed in 1879 by Agnes Mary Clark, and the photograph showed the planet's banding and great red spot, which actually used to be a lot bigger, right? Like, it did used to be this size. Apparently this spot is shrinking fairly quickly. Saturn followed soon after in 1885, when brothers Pierre and Matteo Henry captured these images of Saturn and Jupiter, showing banding and rings. Mars took a little bit longer, I think mostly because it's just like a rock. It's like a little rock. So in all of the photos, it just kind of looks like a blurry rock. But this series of photographs by E.S. Holden shows the ice caps, which are notable features of this otherwise unremarkable rock. It's cool when it's in color. I mean, it's red, but in black and white, it's just like a rock. Sorry, Mars. Later on in the 19th century and into the early 20th century, scientists developed methods of photographing forms of light and radiation that are invisible to the naked eye, such as microwaves, X-rays, gamma rays, ultraviolet radiation, and infrared radiation. That one came a little bit later. This enabled them to see the invisible phenomena that are pretty key to understanding what's actually going on with a lot of the celestial bodies. You know, redshifts and radiation and all of that. And speaking of invisible phenomena, I have not mentioned spectroscopy yet, because honestly, I don't 1000% understand it. And this video was already a lot of research without getting into like the depths of how light waves are broken up and visualized. But the development of spectroscopy was pretty key to our understanding of how far away things are and what they're made out of. As I understand it, you are basically studying how matter interacts with radiation, like light, which can inform you about the composition, structure, and distance of celestial objects. Early spectrographs were made by dispersing the light that comes through a telescope through a glass prism, which breaks the light up into wavelengths that you can then photograph. And Henry Draper made use of this technology to take inventory of the spectra of the star Vega in 1873 for the first time. Spectroscopy was adjacent to photography in that it used photographic materials to capture wavelengths of light, and it helped to guide astronomic observations. You peer at distant stars and compare their light emissions to those of our own sun and other nearby stars. Equations were developed for computing how far away things really were, and hang on, things are really far away, aren't they? Like, really, really far away. So, up to this point, the general consensus was that the entire universe was the Milky Way galaxy. And the galaxy had a lot of stars and nebulas and fun things in it that were being observed and photographed. But that paradigm was shattered in the 1920s when Edwin Hubble, the guy that the telescope is named after, used the variable emissions from a certain class of stars found in certain nebulas to prove that they were actually really, really far away. Like, far outside the Milky Way galaxy. And in fact, these nebulas that people had been observing were actually other galaxies. And Hubble got to work on this. He was grouping and classifying galaxies based on their appearance in photographic images. You've got your elliptical, spiral, barred spiral, and irregular galaxies. And Jesus, there are a lot more of them than you would have thought. I can't imagine making this discovery. Like, I remember being a kid and learning about the size of the universe in school and then looking up at the sky just like, ugh. Now, I can only imagine how it would feel to think that the universe is this nice little thing that makes sense contained within a cloud, only to realize that it's actually a near infinite realm of astronomically large oddities that make no sense. And a few years later, Hubble would observe that these galaxies are actually moving away from each other. So this space, which is already unfathomably large, is actually getting bigger for some reason. Ugh. Space creeps me out, man. Like, what is going on up there? Okay, so back up a bit. Early 1900s. People are looking up at the sky, trying to figure out what's going on up there. Why is everything moving? How is it moving? And there's a pretty important action that is making a lot of that movement happen. Gravity. And Einstein is down here puzzling it out. In 1915, Einstein's theory of general relativity explains that gravity is not a force, like magnetism, but rather an effect of the curvature of four-dimensional space-time. And massive objects interact with space-time. It's like putting a bowling ball on a trampoline, right? Have you seen this demonstration? And then things will orbit it, but eventually get pulled down towards the ball. So if this is true, right, then you should be able to observe the bending of space-time around a really massive object. And a perfect example of a nearby massive object is the sun. And you can observe this bending by seeing how the light from the stars behind the sun interacts with the area around the sun. If space-time is actually being bent, then the starlight will be bent and the stars will appear in different positions than they actually are, having been measured properly months earlier. But the sun is really bright and it overpowers everything else when you try to take a picture of it. You can't actually take a picture of light coming from behind it because there's so much light coming from it. So if only there was a way to cover the light from the sun and only get light coming from behind it, well, luckily, that is exactly what happens in the case of a total solar eclipse. And thank God the moon is like exactly the right size and the exactly right distance from Earth to completely cover the sun. That really worked out well. Okay, so if we want to prove Einstein's theory of relativity, we have to take a picture of the sun during a total solar eclipse and observe how the stars behind it compare to their actual documented positions. Easy enough. The game was on. Now, Einstein had actually written a paper predicting the amount of light deflection in 1911. So saying, I think the stars will be in these positions, judging by how heavy the sun is. But those calculations were flawed due to an incomplete theory of relativity. But they didn't know that yet. So in 1914, there was going to be a solar eclipse, and so 3 expeditions set out to photograph it, and attempt to prove these flawed calculations. The first expedition was a bunch of German astronomers traveling to Russia in 1914. The second was an American expedition, and the third was Argentinian. Unfortunately, 1914 was kind of a big year for Europe, particularly Germany and Russia. And so the start of World War I happened right in the middle of the expedition, and this meant that the German astronomers traveling to Russia were either detained or sent home. War's bad for science, guys, pass it on. The other 2 expeditions were unimpeded by the war, but it was cloudy in both locations, and so they were unable to capture the required picture of the solar eclipse. Luckily, another opportunity to capture a solar eclipse would present itself in 1919, after the end of the First World War, and after Einstein had published his more complete theory of relativity. So, expeditions were launched to West Africa and Brazil that would come to be known as the Eddington Experiment. And it worked! There were some trials and tribulations. It was cloudy in both locations during the morning of the eclipse, but the clouds cleared at the last minute, and dozens of photographs were taken. The guy said that he was so busy taking photos that he didn't even see the eclipse, which is kind of sad, but out of 16 photographs, 1 showed enough stars to corroborate Einstein's theory and demonstrate that light was indeed being bent around the sun. And that is so cool. Oh my god, it's so cool. Photography helped prove general relativity. That is probably a good stopping point for this video, because now we're getting out of like the early dawn of astrophotography and we're getting more into the modern era. We're getting more of a modern understanding of how things work, right? And if I keep going, then we're gonna have to start talking about space flights and early photographs taken from space, which is very interesting. For example, did you know that the very first photograph ever taken from space was taken by a movie camera strapped to the back of a V-2 rocket that had been confiscated from the Germans by the Americans after the Second World War? That's a fun fact. So much great history to talk about. I'll probably do a video at some point on 20th century astrophotography because there's a lot of great stuff to talk about. I've talked about some famous astrophotos in my iceberg series, which I will come back to at some point soon. And it would be sweet to talk more about the groundbreaking Hubble telescope photos. Maybe I would even talk about Beatrice Villarreal's recent unexplainable findings after examining historical astrophotographic plates. She found a lot of really strange things up there before we had any satellites up there. Great UFO stuff. I'm not going to talk about it now. I actually really restrained myself not adding that into this video, so you're welcome. Thank you all so much for watching. Remember to check out today's sponsor in the link below. Use my code YHansen at sign up. And if you're interested in supporting the channel in other ways, I will also have some links in the description below. You can buy me a coffee. That's a one-time $5 donation, and all donations made through this link go directly to improving the quality of videos that I'm able to offer on this channel. So I really appreciate anyone who considers that. Thank you so much. These longer, more research-intensive videos are indeed intensive, so any support goes a long way. I also have a link to my print shop down below, so if you're interested in buying any prints for the holiday season, you can go check those out. If any of them speak to you, that would be fantastic. I will see you all in a few weeks, probably like the second week of December, and I'll be back with something new, either commentary on Annie Leibowitz's recent Vogue cover, which I have a lot of thoughts on, or the third part of my iceberg series. I'll see how I feel and what my workload is looking like. In the meantime, I want you all to stay sharp and don't forget to keep shooting. Bye, guys.